So I have this game engine, right? It's called the Tails engine. And I finally kind of have a distinct direction that I want to take it. And that direction is Game Boy Advance style kind of graphics and feel. So I need to kind of really simplify it, because at the moment it's a bit complex, a bit big, a bit bloated. I've just kind of been adding stuff, not really caring what the end result is, just because I want to, like, you know, conquer the things. Like, for example, this input stuff. There's no need for it to be this complicated, but I made it this complicated because I just wanted to prove to myself that I could implement it at this level of complicatedness. So for this new kind of version of the Tails engine, I want to just strip it back to, you know, as basic as possible, because it doesn't need to be complicated. It's meant to be just a simple 2D pixel art based game engine, and that's it, right? Game Boy Advance style kind of stuff. That's it. The only complicated things would probably be like implementing, you know, module audio support kind of thing, right? So anyway, that's the kind of target, is taking kind of the architecture of that engine and just simplifying it. So I had a bit of a think, right? I'm gonna, you know, make a new folder here for it. I kind of had a bit of a think of different, like, you know, new architectures and stuff. And I was thinking I might, you know, but I was thinking it would probably be a good idea to go with like either a singleton for like the engine, right? There's only one engine and it just exists everywhere. Everything has access to the engine, or a global variable where, once again, everything has access to the engine. It's just two like different ways of accessing that global thing. One of them ensures that only one can exist, while the other one just has, you know, a global overarching thing, but context specific stuff can also exist. So I was thinking that, and the main reason why I was thinking that was because I kind of wanted to move away from the idea of outers. Outers is a concept that I got from Unreal Engine. I look through Unreal's source code quite a lot, quite regularly, and outers are quite a big thing in that engine. Basically, an outer just references to the objects that this object is currently owned by, or in, right? So, for example, the level owns all of the entities in that level. So, the outer of an entity is the level that it's in, right? And let's say, you know, a world object manages all of the current levels and stuff, manages like opening levels and stuff like that. The outer of the level would be the world object, and then the outer of the world object would be the engine. So if an entity wanted to get the engine to do whatever it wanted to with it, it would just query the outers, loop through them until it found the one that casts successfully to engine. And that works. But I was just thinking, is it kind of pointless to have that though? Could I just make a global variable or something instead? And I'm thinking, yeah, but which one's better, right? Because obviously I could have a base object class, and then things that I, you know, don't want to have outers or something just don't inherit from the object class, which makes sense. Yeah, I'm just not entirely sure, because I was also thinking, you know, the input system doesn't need to be tied to the engine. It doesn't need to be a member of the engine. It can just be its own singleton or something, right? Like Godot, the input class is a singleton, and you have like static methods for stuff, I think, anyway. Whereas in Unreal, the input is like funneled through different objects to finally end up at the like current possessed pawn from the controller, and so on and so forth. That is like very tailored towards that like gameplay concept. I want it to be more general than that. I don't want it to be super general like Godot, right? Godot is like, you know, nodes, and everything's a node, and it's all confusing because everything's a node. It's all a bit weird. But I also don't want to be like Unity and have like components. I don't really like the idea of componentizing things. I haven't like spent too much time in component based architecture, but from what I have tried of it, I don't like it too much. So I want to go with like the Unreal route of inheritance trees and stuff, just because I feel comfortable doing that. Yeah, and it's not going to be like, a huge, commercial engine or whatever. It is just for my own kind of personal projects or like my own learning stuff, basically. So it doesn't really matter the end result. But anyway, yeah, that's the kind of idea. Gonna have like an audio manager. Whether these things are going to be members of engine or just static stuff on their own, I'm not sure, because if they're static, the engine's going to have to call them to update them, right? So for example, the input subsystem, to be able to kind of have a state for input just pressed last frame, but not so if an input is pressed but it was also pressed last frame, then don't call the just press thing. That would need some kind of update loop to check the current state and then check the state last frame as well. So if I don't have that, then I don't need to tick the input manager. And I think that's the kind of thing I want to do, is just not tick anything except for like the world, which will have levels and entities, and the UI stuff, which will have widgets and stuff. I think that's it, because we will have the asset manager, which doesn't need to tick, that just needs to be able to create assets and get assets. The input manager, which just needs to have static stuff to query if a current key or like key code ID thing is pressed, or what its like current analog state is, or scalar value, that kind of thing, if I even support that. And then also an audio manager, which will just play sounds and music via like the SFML interface, basically. And then the engine, which will contain the world and the so the only things that will be like a member of the engine will be like the world and the UI stuff. And I think the window that it draws to, I'm not entirely sure on this yet, but I think maybe just having the engine draw to a render target instead of a window would make it more versatile, because then you could draw to the render target, get the render target for that frame, do stuff to it, and then draw it to a window. Yeah, I think I'm probably going to have stuff like that. That would probably be nicer. Yeah, I'll probably do that, because in SFML I can show you the documentation actually. The render window, which is what you'll probably use as like the main window subclass, is render target. And render target has two children: the render window, which is probably going to be like the default thing. So if you don't change, like, because render target, is it an interface? I don't know if it's abstract or not. No, I don't think it is abstract. So yeah, we could just straight up have, no, it is abstract, never mind. Yeah, so render target is that, yeah, oh yeah, it says abstract right here. So yeah, you'd either need to say, put this render target onto a final render window, or yeah, because it will be a pointer to a render target, and that render target will either be a window or a render texture or whatever else, whatever like custom thing you want to subclass from render target. Yeah, by default it'll be a render window, so by default the engine will just be drawing to a window, I think. But a render, yeah, or yeah, I don't know actually, but we'll get to that in time. The thing I want to do right now is just make the kind of make a basic thing that works essentially. Yeah, make a base object class with an outer pointer. Make maybe a tickable interface, which provides like ticking methods for stuff. SFML has a drawable interface, so I'll just use that, or make my own. I don't know, because then the entity I suppose it depends on what the entity would be. Anyway, yeah, it would be like, basically most things I want to be interfaces, and not concrete classes. I don't actually know if the diamond problem exists for pure virtual functions. I want to look this up. Oh, okay. So it doesn't really matter, actually. Yeah, I don't really like the idea of having virtual inheritance. But if worst comes to the worst, I can use it. I don't really like the idea of it, though. But basically, pure virtual methods or member functions, these two technically have different implementations. So which implementation does this class use? And obviously you would just call the parent one in it, right? You'd override it to provide its own implementation, and then that's the one it uses, its own implementation, overridden from both of these. And because it's virtual, it can just work fine, right? Like these are virtual. I don't know. Anyway, CMake lists. I'm going to use CMake for this just because CMake's pretty decent. Yeah. CMake's pretty decent. I'm also going to use CPM as well. CPM is really cool. It's this basically kind of a package manager for CMake. It's super simple as well. You just you literally just write this and it works. Yeah, obviously there is this thing. You need to have CPM as a dependency, but that's really easy to do as well. I don't know what version of CMake they depend on, though. Is there a... hang on. Is there like a version thing in here? 3.14. Okay, I'll just use 3.14 then. It's like pi, isn't it? Let's have a fatal error with that. So the project is going to be called Tails Engine, let's say, with C++, and we want to add CPM. So once again, adding CPM is super easy. I think they actually have it in their wiki. Yeah. Where is it? Downloading CPM. Here we go. It's literally just this. Copy that, paste it. You don't even need the hash. I found out you don't need the hash, and you can also go. 40.1 is the latest. Let's go with that. And then that's it. You can then just say CPM add package, and I want SFML. So we're going to GitHub SFML/SFML, user/repo, and then it's a hash for the tag. And you'll notice in CPM, some of them have a hash, some of them have an @ sign. The @ signs are for the tags with a V in front of the versions. So this basically v0.40.1 instead of just 0.40.1. SFML doesn't have the V, so you want to specify the tag explicitly, whereas if you have the V, you can use the @ sign. I don't know why there's two. I don't know what the point of them is. Maybe there's some other thing, but SFML is going to be 2. Actually can't remember. Is it 26 or 6? I cannot remember what the version of SFML is. 2.6.1. Yeah, so SFML, the tag is 2.6.1. Here you go, you can see that there. And it's not got a V in front of it, so we can just use the hash. And I want to set some variables as well to do with SFML. I can't remember what they're called. So let's go to the documentation. Hang on. Here we go, CMake. There's a list of them here. Here we go. So we want build shared libs. I don't want shared libs, so we can set that to off. And then we also want use static standard library on. So I'm going to build it statically, essentially. This can only be on if this is off and vice versa. This can only be on if this is off. You can't use them together. But, you know, I'm going to comment this saying build SFML statically. And then add SFML. This I'm going to call it download CPM. Download and include CPM. Okay, so now we're going to have SFML downloaded, and it's going to compile statically and link statically. The thing we need to do now, though, is make a library. Personally, I do that in my source directory. So I add a subdirectory, and what I'm going to do is have source, which, you know, this is the root, root source. So folder structure will have Tails engine, and then source. Yes, the file structure is, you know, the CMake lists, source, and then in here I'm going to make another folder, call it Tails. And I got this like structure from SFML just because, you know, SFML, they have include/SFML, and then the stuff here. And the main reason you want to do it with the include stuff here is because when you do like, you know, hash include, you'd have to specify SFML/ to get the SFML stuff. Otherwise, you'd just be able to say like graphics.hpp, right? And if any other library that you're using has a file called this, it's going to crash. So it's almost like a namespace for includes, having another folder, right? You can treat this almost like a namespace for files. So Tails here, and then I'm going to make another. Actually, yeah, here we go. /Tails, and then that's the directory that we're adding. I will do the same for the include directory, but just not right now. So we can add a CMake lists file here. All we need to do here is specify the project, Tails engine, and then we can add library. And I'm going to call this Tails engine. Doesn't really matter if it's the same name as this, the project, and this is called a target, by the way. So when you see like, you know, target link libraries, target include directories, this name is what it's referencing. This is a target. So before this, we don't have any targets. Tails engine is not a target. Tails engine is the project. So chances are you want to differentiate the project name and the target name. Doesn't really matter. You can have multiple targets in the same project, so you can have a library and an executable if you want. Doesn't really matter. I'm going to add a library which adds the target Tails engine, and then I'm going to make it a static library, right? Or if you wanted a shared library, you could do that. I'm doing static, and then you specify the files. You can't add a library or an executable without specifying at least one source file, and that's why I like to do it in the source directory, because I don't want to be, you know, adding a library here and then, you know, going down the line here just to add a single file. I'd much rather just specify the add library in here and then, you know, do something like target sources later, which just adds source files to a target, for example. Tails engine, right? Target. So I'm going to just say object.cpp, and that can be our lone target, our lone file for now to be compiled into this target. So now we have a valid target, and we want to link SFML to this target. Right, because SFML here, this is just being downloaded to our local thing, and it will be compiled when we generate the build system. So when we generate a solution, we can then compile SFML. But it won't link because we haven't told it to link. So we can say target link libraries, not directories. Target link libraries. Now, the target that we want to link a library to is Tails engine. I want it to be public just because I want the person using the Tails engine library to be able to access the SFML library as well. If it's private, the user using Tails engine as a library won't be able to access SFML, which if you're including SFML headers in your own library's headers, that could cause link errors and stuff. So just be wary of that. I prefer to use public over private anyway, just because, I don't know, I just prefer it. I don't know what the standard is. I think you're meant to prefer private over public. Like with classes, you're meant to prefer having private members over public members, but it doesn't really matter that much, I'm going to be honest with you. Yeah, so we can then say SFML graphics. I think it's graphics and not graphic. So what is this? This is a target as well. So we're linking a target from SFML, right, to the target Tails engine. Yeah, this is a library target, much like this is a library target. So if someone was trying to do target link libraries to Tail engine, they would say, you know, like target link libraries, you know, example game, Tails engine. Right, they do something like that. So it's linking this target to this target, which is quite cool. How do you know what this target's called? I'm pretty sure it's in the SFML docs. In this compiling SFML CMake, I think. Anyway, I can't actually remember where I found it. I think I just looked through the SFML CMake lists files and I don't know. Oh, here it is. Yeah, there you go. So you have the list of targets. All of them, builds all of them, obviously. Yes, these are the like kind of main ones. And if you start using SFML's like audio stuff and it fails to compile and stuff, then you might just be missing SFML audio here, right? You might just be missing to link it. If you link SFML graphics, then I'm pretty sure it links system, window, and main for you. Main's only on Windows, so we can kind of ignore that. But graphics relies on system and window, I think. So when you do graphics, you get these two as well, to my knowledge. And then the rest you've got to do separately, like audio and network. System is used in all four of these. Audio uses system, network, and stuff. They all use system. So you're kind of forced into using system. But you can just use, you know, window and system or network and system. You don't have to use, you know, audio or graphics. You can, you know, pick certain ones. So currently I'm not going to be able to use the audio functionality of SFML because I'm not linking it. So that was a lot of talking. So we linked it, and it will just work now. But if I go into here we go. If I make an include directory, right, include and source, that's just standard for C and C++ projects. Make a Tails folder, kind of a namespace, as I said before, for files. And then I make a object.hpp. I prefer HPP because it's like CPP but headers, right? Where in C it's, you know, object.c, object.h. I prefer in C++ object.cpp, object.hpp. Kind of just makes sense to me. And SFML does it as well. I base quite a few things that I do off of what SFML does, just because SFML's like, you know, proven to. It's a proven library basically. So, you know, it's only really a good idea to kind of base that stuff off there. So I don't have the object file here. Let's add object.cpp in here. And if we go include tails / object.hpp, this won't work at the moment. Why? Because we haven't set our include directories. That's really simple. Target include directories. The target is Tails engine. We can make them public because we want all of the users of Tails Engine to also have access to these include directories, and we can just say include. Include being the file here, so they'll have access to everything here basically. So Tails / kind of stuff. This is highlighted just because Notepad. There's an actual command in CMake called include, and Notepad just highlights every single word that is include, just because that is a command in CMake. So this isn't like a special thing or anything. It's just highlighted because it's a command in CMake. Yeah. So you might be thinking, well, don't we need to, set the include directories for, SFML stuff as well? No. Why? Because if we look at SFML CMake lists and just go to target include directories, it's not actually in here for some reason. Is include? No, it might be somewhere else. I don't know. Maybe it's. I don't actually know. Where's the? Is there a CMake list here? No. Is there a CMake list here? There's a CMake list here. Is it in here? No. Okay. Well, it's not here for some reason. But basically, if you set it to public, then when you link it, it kind of sets this by default, right? That's what I'm saying with when you say, yeah, so when you set it to public, everything that uses your library can access the include directories that you set, meaning SFML set its own include directories and we're accessing them, which means we don't need to set our own ones for SFML. We just get it by default because we're linking it, which is super cool. So that should be the complete CMake lists thing. I do want to add target compile features. This is features for compilation, i.e. stuff like the C++ version. So the target Tails engine, I'm going to make it public because I want everyone using my library to use this C++ version. Say CXX standard 20. Just because, I don't know, why not? I think I can probably get away with 17. I'm pretty sure I need stuff from 17 though, so I can't go below that, I think. But yeah, really, anyone who's making a new project using your library, unless they're integrating it into an old project, which chances are, if you're making like a game engine like this, they're not going to be integrating it into an old project. Doesn't really matter what version you use, as long as it's supported by the compiler that they're using, which C++ 20 is mostly supported by most compilers at this point. Yeah, you can see the compiler support for stuff by just searching C++ compiler support. I think it's CPP reference that. Yeah, there's a huge table on stuff, so you can see with C++ 26, which hasn't. I don't even know if it's been standardized yet, but I think it has actually. Wait. I don't know if it has. 23 of many tiers is a. I don't know, but something I want for 26 is a reflection. I was reading through the proposal for C++ 26 reflection, and it looks like people want it. They just have a bit of an issue with the caret symbol this have been used for it, because apparently it's used in like one other place in like the Apple compiler, and they're like, we don't want to ruin the Apple compiler, so we might have to change the symbol. Yeah, I don't know. Anyway, hopefully it comes some point soon, because reflection would be sick. Anyway, you can see the different compilers. You can see that MSVC is kind of slow on its stuff. MSVC is Microsoft Visual C, which is like Visual C++. That's Microsoft's compiler for solutions and stuff in Visual Studio. So for Microsoft Visual C, Visual C++ kind of thing. It seems like it's a bit slower than everything else. Right, GCC and Clang are like ahead of the curve, but MSVC for C++20 it seems to be pretty good, better than GCC and Clang actually. Modules is like you know, modules has still got a little ways to go. So you know, anyway, yeah. So I'm choosing 20. 26 isn't even released, I don't think. So you know, anyway, yeah. So that's the standard. What I want to do now is just add some boilerplate code just to have it compile or something. Yeah, it doesn't even need any code in it, I don't think. Actually, since we have the include directory now, I might as well make a CMake lists file here for the include stuff. The project is going to be Tails engine, and we can say target sources, which is how you add source files to a target after you've declared it. The target is Tails engine, the library. I think you can specify a thing here, public, and we can just say object.hpp. I think there's the visibility thing there. I don't actually know. CMake target sources. Yeah, there is. So yeah, I'm making it public just because why not, really. So there we go. So now we can add the subdirectory. And add subdirectory, I think, pretty much is like include in C++ and C. It just takes this, puts it into where this is. I think. I don't know. It's probably similar to that. It's probably not exactly that, but yeah, you only need to specify the project and the subdirectory stuff, not the CMake version or anything. Just the project that this will be associated with. Which is quite nice. So include /tails. That's that. Once again, include highlighted just because it's a keyword. Now, if I do a quick header guard here, Tails objects HPP. My header guards, I prefer to have the namespace, then the class name, then HPP. But just because you want it to be globally unique at all times. Yeah, and then we can put it in the namespace of Tails. I'm picking Tails because from what I've heard from different people, 5 letters is like the max that you kind of want a namespace to be until it becomes like really cumbersome to type it. 2 letters is like a nice amount, so like TE would be quite good for, you know, Tails engine. But I don't like the namespace TE. It's, you know, TE. It's a bit stupid that I don't like it, but hey, whatever. Tails is nice. It's not too long, and it just makes so much sense in, you know, regards to the Tails engine. You know. Anyway, that's Tails. Yeah, the kind of the naming convention of namespaces is all undercase and quite short. Doesn't matter what you put it as long as it's like it makes sense, really, because you can do like aliases and stuff, right? You can say namespace, you know, namespace TE equals, you know, if I were to put like Ostanton Tails, right? If I were to wrap this in another namespace, right, called like Ostanton, and then everything that I make will be wrapped in Ostanton, and then the sub-project like Tails or my delegates library would just be wrapped in this, which I'm actually thinking of doing. But you can make a namespace alias, and so then here you can just say, you know, TE object or whatever, right? It just essentially does it instead of this, which is quite cool. Don't need that though, that's fine. So, basic object class. I'm deciding the kind of grammar I'm using for this is C prefix for classes, concrete classes, I prefix for abstract classes, S prefix for structs, T prefix for templated structs or classes. That's more or less it, really. E for enums, kind of like Unreal, but also not really. I think the source engine does this. Yeah, I don't know if this is like an old practice or something, but it just kind of makes sense to me. Especially if you have, if you're using a text editor which doesn't really provide you support for, you know, is this a class or is this a struct, or, you know, what is this? Because in languages like C# and D, where the double colon syntax isn't a thing for namespaces and static stuff. If you don't prefix a class with like C or something, you don't know if it's just an object with a capital letter starting, or if it's a class or a namespace, because they all have the same dot accessor. You know, you could say, you know, object dot this, and is object an object or is it a class? I don't know. I'll have to mouse over it or look at the color of it. Whereas C objects, especially with the double colon, you know exactly that it's either a namespace or a class, and you know it's a class because it's got the C in front of it, or that it's that it starts with a capital letter, kind of thing, right? I like, you know, even though it's slightly more verbose or whatever, it just makes more sense, right? You can see at a glance it's a class, and you're accessing a static class member because double colons, so it's either a class or a namespace, and C, so it's a class. You know, you don't need syntax highlighting, you don't need to hover over it or whatever, you don't need to go to definition, you just know. So I want to have public, I don't know if this will be public, but for now it will be, have a pointer to the outer, which will be initialized with null pointer. And I prefer using this just because, I don't know, actually, I don't know why I prefer this. Ever since I started doing it, I was like, I don't like this anymore. I don't like doing that. I prefer the brackets, the curly braces, just because then you can also differentiate easier between initialization and assignment, which I think is quite cool. Anyway, so now we have an object. Yeah, so here we can include it and just set the namespace again to tails, basically. And also what lots of people do is they say, you know, is they put a comment at the end of this, especially if you're using multiple namespaces and you're nesting them, you really should do this. It's like preprocessor ifs. You need to comment the end if of what if it's relating to. Yeah, like this, for example. This end if is relating to this if, of if this is defined or not. So, yeah, anyway. We have this now. So, if we did everything right, I'm going to make a build folder. Open in terminal. CMake ... is the basic command. Run it from the build folder. You don't have to run it from the build folder. You can run it from anywhere. Because the CMake command has different like options. Yeah, you can specify -s for the source and -b for the build directory. But you can straight up, because you've specified in CMake here these things and stuff, you can just run CMake ... which is, you know, specifying the location of the CMake lists file, the main one, this one. You're specifying ... which is upper directory into just Tails engine. You're specifying it there, saying, you know, run CMake on this file. Then you run it, and it's going to be doing it for Visual Studio 2022, which is good. That's the one I have. It detects your compilers and stuff, so if you don't have a C compiler or a C++ compiler, it'll be like, hey, you should probably get one of these. So CPM is doing its thing, adding SFML, which is cool. It's doing stuff, and the build files have been written to the build folder. So now if we go to the build folder, bang, we have all these files. These were generated by CMake. Underscore deps is the dependencies, so SFML is in here, the source of SFML is in here. Yeah, the entire GitHub repo for it is in here. I think maybe the entirety of the Git history. No, it wouldn't be the entire history. It's only the tag, this. So it's going to be the entire repo at that point in that tag. I don't actually know. I think you can do a shallow one, which I don't actually know what shallow does, but it like omits certain things to make it so that you only download what you need. I don't really care too much, but that's probably something you want to look into if it's, if it's necessary. I don't know. Anyway, you have a build, sub build. These are for CMake things. I don't really know. You have include, which is, include for your projects or for your target. And then, the project is going to be the solution name, and the target is going to be a project in that solution. So you can see SFML, you have these graphics. Because I included graphics, or I linked graphics, it also links system and window, because graphics depends on system and window. Tails engine, this is the project, and this is the target. I could make another target and call it like, Tails 2, and it will appear as another project in the solution, which is quite cool. So you can see we have object.cpp and object.h. They're kind of grouped together here because we've added the header as a source, and because they both have the same name as the parent folder, they're grouped together in the solution. SFML also has this, right, even though in the source you can see they're separated into source and include, the solution just shows it as them being together because they have the same parent directory, SFML, in both of them. So yeah, don't worry about that. These little blue arrows, I don't know what they mean. I think probably just because it's being tracked by CMake lists. I don't know. Anyway, we can go to object, see that, go into here, see that. So you can edit the code in here as well. What you'll find yourself doing is probably editing code in here, and then basically just doing that. Yeah, I prefer to use C-line, especially when I'm adding files, just because I don't really like Rider's integration with CMake stuff. But C-line's integration with CMake is quite good. So yeah, I like using that. Anyway, so if I say include, I can just start typing SFML and it comes up because we linked it. So all of the headers are here and all that stuff. That's all good. And if we go in here, you can see that this shows up. I can say, include Tails. Tails comes up, object comes up. So that works. Congratulations, you have made a thing. We can do an all build, which will build everything that the project requires. This is generated by CMake. You have, zero check and stuff. CMake has these 4 configurations by default. I only ever use debug and release. I don't know really what the other 2 are for. You can check if it's debug or not with a preprocess and macro. If is it ndebug or just debug? Maybe it's that. No, actually no. Ndebug will only show up if you're in release. Yeah. Okay. So yeah, ndebug is predefined. It might be predefined from SFML. I don't know exactly. Then you can ndif, and then obviously you can say ndebug, right? Because this might be relating to this. So you want to specify ndif here is relating to this if. So this will only, all of the stuff in here will only trigger if we're in release. Ndebug means not debug, basically. It's a bit stupid that debug and then ndebug is release, but you know, yeah, you can make your own preprocessor definitions. There's a thing called target compile definitions, say Tails engine public, and you can just say, you know, Tails def, for example, Tails def test, let's call it, right? Save it. I'm going to get rid of this. And now if I run CMake again, it doesn't re-download this because it already has it. That's the work of a special CMake cache. CMake cache basically says you're trying to download SFML. Hold up, you already have SFML, and it's like, okay, cool, we don't need to re-download it. So CMake cache is quite cool, but you might want to delete it if certain things aren't. If you change something here and they aren't like showing up, you might want to delete it and then regenerate the build stuff via CMake because it might not update sometimes. But it will probably re-download everything if you do that, so just be wary. So if I open Tails engine now, we should just have this defined so we can do an if on it, right? Say if Tails def test. There you go. And if, right. I don't know where the closing braces went. Yeah, so that's just there now. Right, and I think we can set a value to it and stuff as well. So what you can do is you can have, you know, an if something, you know, if platform is Windows, define Tails Windows and stuff like that. That's really cool. That's a cool part of CMake. You can do that. But yeah, so you can do preprocessor definitions and stuff based on the platform, based on the compiler, based on, you know, a bunch of stuff, based on what the language version is. So I'm just going to compile the debug build of this and make sure it does compile. It should compile. If it doesn't compile, then that'd be a bit annoying. This is doing the CMake thing just because I changed that so the file is different to what it, you know, was loaded in here. So it's compiling SFML because it downloaded the source code, so I've got to compile it. There you go, so it built Tails engine as well. We can do it for release as well. And this should all succeed, right? Because it's compiling it all based on your system. What I found in the past is if I was downloading pre-compiled binaries to SFML, the release version wouldn't actually work. It would have linker errors. I don't know why exactly, but I think just because it was built on a different computer to mine, so it's like slightly off or whatever. Yeah, anyway, that is that. This is just like a CMake tutorial that I'm doing for some reason. I'm trying to remake my engine, but I'm turning it into a tutorial. Doesn't really matter, it's all good. So what I need to do now is make sure SFML stuff actually works. So make sure I can call methods and display a window. So what I'm going to do, I haven't actually done this before, so this will be quite interesting, is just make a project in here. I'm going to make a folder, called it, like, let's just call it tests, actually. I've never done like C-test or whatever. This probably isn't what you're supposed to do, but I'm going to do it anyway just because I want to do it quickly. I'm just going to make a main dot. No, I don't want this pub file. Make a main dot cpp. Goodness me. Here we go, main.cpp, and I want to, you know what, this is fine. We can just include Tails object int main return 0. Yeah, so I want to make sure Tails works, and I also want to make sure SFML works. I'll do that in Rider though. So that's main. I want to then add executable, call it test app, let's say, and we can just specify test slash main.cpp, and then I want to say target link libraries. Target will be test app, and I want to, let's say private actually. Let's do this and see what it's like. Test app private, and I want to link Tails engine to the test app. I don't know if I need to do that actually, since it's all in the same kind of project, but we'll see. So link it. This means it will do the stuff up here, but for this, I don't know if that'll work actually. I don't actually. Let's try it without it. See if it works. Let's regenerate the CMake stuff. Tails engine solution. We should have another project in the solution. Yeah, we got our test app. That's here. We have our tests main.cpp. So yeah, okay, it can't find it. I go Tails, no. SFML, no. Okay. So I'm pretty sure that is because we haven't linked it. So if I get rid of that and I link it, now if I run it again, run CMake again, and I open the solution again, it should work. Yes, it works. Okay. So now I can include SFML. Brilliant. I can include SFML. So that's good. I want to create an object. Actually, it's in the Tails namespace. Here we go. It's the object. Just call it object. And then we can do object.outer. Nice. Equals itself. I don't know. Yeah, so we can do that. Make sure that works. Actually, let's make a method here. Say void hello world. Let's do that. Let's include IO stream hello world. Right, like that. And then we can say objects.hello world. And then we can just make a simple game loop quickly. I do this with this one, SFML and Visual Studio. I don't know about the others, but this has a nice example here. I'm just going to include SFML graphics header, and then in main we can just copy this, put it in here, bang. So this doesn't have any, syntax stuff going wrong. So if I go into debug and I go into test app and I play, I know that it won't. Hang on, it's a linker error. Oh dear. We have something strange happening. This is very strange. SFML window S debug, right? Static debug. Lib link mismatch detected for runtime library. Very strange. I've never seen this before. Let's have a little look. Let's look this up, shall we? What does this say specifically? Say SFML public. Hang on, wait. Is it just mismatch or? Yeah, mismatch detected. Mismatch detected. LNK. Let's have a little look. A simple problem. Yeah, mismatch detected for that. Doesn't match. Read the dependency list. Okay, so apparently we're not. If you want a static link, then remove static features. Maybe it's a better link. Build static. Let's I don't want to open it in a new window. How do I link it statically? Okay. Sure. Maybe it's because I'm not setting the things correctly. Let me go to the CMake cache. Yeah, you can see build shared libs is off, which is good. That was this. Build shared libs off, and then use static standard libs. That's on. So it is using static libs. However, something is strange. You need sort of SFML. Here you go. There's something wrong. Because the build stuff is in, where is it? Is it this? Yeah. No, it's not. Never mind. We have, where is it? Debug. This. Has it just not built SFML then? Wait. All build. Where's SFML then? This is the Tails engine library. Oh, it's probably in here then. Yeah, okay, so it's been built here. So, hang on, I want to try something. Goodness me. If I go here and then I just change this to public. Let's go back and see. Object.h is here now. Why is this in the test app? Where? What? Why is that in the test app? Oh, probably because I set it to public. Oh well, let's see if this works. No. "84 errors." Oh. So, okay, obviously it's not linking correctly. That's a given. I'm leaving it as private, but why is it not linking it correctly? Good question. Good question. Let's look at this. The CMake list of the old Tails engine. We have target link libraries, public, SFML graphics, yes. Yeah, seems like we're doing everything the same. I'm going to add this quickly actually, just because I feel like it would make it, well, it wouldn't fix it, but, you know, just saying current source dir, just for future reference. I don't know why it's not working. I'm gonna see if if in here, if I include no, if I don't do it in here, if I do it in just the source file, SFML and then graphics, and then run this in here, see what that does, and then instead of doing that, get rid of that, right? Okay, so Tails engine compiles just fine. No, it doesn't. Never mind, Tails engine does compile just fine. Main.cpp does not. So, it's definitely a problem with the executable. I actually don't know. I really don't know. Because it is public, and it compiles Tails engine just fine. I'm going to close it, regenerate, CMake again. And try again. Because object here uses SFML now. It's not in the header, so this shouldn't use it. SFML isn't being referenced at all in the actual executable. It's being referenced in the compiled, statically compiled source file here. So it compiles Tails engine fine, unless it's... That's so weird. That's very weird. I don't... What? Unless it's not actually compiling the objects thing here. But we have this here. Object.cpp. So... You know... I don't know. I am bamboozled and perplexed. I'm just going to ignore this for now and get on with writing the engine, and I can test it with an external thing later, I think. That's what I'm going to do. I'm just going to ignore it for now. And just assume it'll work. Yeah, that's what I'm gonna do. So, yeah, I need to create the engine stuff now. So the engine header. Put this in CMake lists. Engine.hpp. The engine header. Gonna do this. If not defined, Tails engine HPP. Then define it. Then we can end the if. Should I explain what that thing is? It's called an include guard. If you don't know, oh goodness, if you don't know, it's called an include guard. Guard, not God. It means if this is not defined, if endef, if not defined, then define it. Meaning if it's already defined, it skips all of this. Meaning if you include it, like lots of times in lots of different places, it only actually compiles it once, I think, right? Yeah, because this will be defined. This is a definition. Definitions are like global, so if they're defined somewhere, then they will be available anywhere, basically. Yeah. Anyway, class C engine. I don't want this to. Goodness me, I don't want this to inherit from objects because it doesn't need an outer. It shouldn't have an outer. It's an engine. What it does need, however, is a forward declaration of the render target, I think. Go to the SFML documentation. Here we go. Render target. Here, I believe. Yeah, render target. So I know I'm going to need to include the memory header because std unique pointer of SF render targets has to be called render target. There we go. Nice. So now we have our default render target, which is empty at the moment. We're going to have to do something about that. But our public methods, we can have a templated method saying, set render target. And this will simply set render target equal to make unique of t. Although, good idea is to static assert this, right? Because we don't want to make a unique of this if the type of this is not deriving from render target. So we want to make sure that it derives from render target before calling this. If it doesn't, then we fail statically, meaning compilation, I think. It failed compilation anyway, so I don't know. No, it wouldn't fail, would it? Yeah, it would, because templates are compile time. I don't know. Anyway, static assert it is base of v. The base being SF render target, with t being the derive class, and we can just say failed to set render target. Hang on, what am I doing? Get out of here. Failed to set engine render target. Type does not derive SF render target. Bang. This message will show if you put in a type that's not deriving from this, is base off, is a pretty cool function. Right. Or is it a function? Probably. I don't even know. We don't have parentheses here, so, or brackets, so I don't actually know what that's about. Anyway, we can now set that, which will have a default one, which will just be the thing. We'll put it in the constructor probably. Constructor, i.e. CEngine. Bang. So we want a virtual constructor because we want to be able to subclass it. We also want to have it be default, so that's all good. Right, now we need a source file. I don't know why I'm doing everything in Notepad. I should probably use Rider for this because I'm not the greatest at keeping everything coherent and not bug-free, but whatever. Anyway, engine.cpp include tails/engine hpp namespace tails, and we can say, I'm actually not going to have the, I put it in here, didn't I? Yeah, I'm not going to have this comment just because I don't need it, because there's only a single namespace, so it's not needed. What we're going to do, CEngine, yeah, we're doing this. We're just going to call set render target to be SF render window, which we shall include tails / no, not tails, SFML /graphics / render window. I think the file is, I think that's the directory. So there we go, that's cool. So now our constructor calls this. So now this is just going to be a render window by default, and we can override it if we want to with something else. That's all cool, fun stuff. Yeah, it's pretty cool. So that's good. Let's run CMake. And it does its thing. Nice. And we no longer have main. Main doesn't exist. I'm going to get rid of this hello world thing. I don't want it. And I'm going to get rid of this. Don't need it. So now we have engine.hpp. We don't have engine.cpp because I forgot to add it to the CMake lists. That's the problem with CMake. You've got to manually add each one. Premake, it does it for you. You can just specify a folder and file extensions. In CMake, you can glob, but that's not very useful. It's recommended against that because CMake isn't good at realizing when a source file has been changed or something like that. So you got to add each file individually. So if you're, moving to CMake from like a solution, it's going to be annoying. But if you're doing CMake right off the bat, it's fine. So, also notice this. It's saying it's got a default destructor, but doesn't have a copy constructor, assignment, move, stuff like that. I don't care about that at the moment. I can add that later. It's also going to complain about it not being like standard naming convention, like this, for example. Does not match rule. It should be render underscore targets. That's what the standard is. You can change that in the settings if you're using Rider, if you're using anything else, whatever, I suppose. This seems all good. If we compile, it should work just fine. Yeah, okay, so yeah, this works just fine. It compiles, it links, everything's good. No, it doesn't link actually. Static stuff doesn't link with each other. I don't think. Dynamic stuff links with each other, I think. I can't remember, I've got to be honest. Anyway, we have the engine now. That's good. So basically the engine, how it works is you subclass the engine. Do you? You don't need to subclass the engine, it doesn't really matter. You can set properties outside of the engine. It just kind of makes sense to subclass it, I suppose. Yeah, you don't need to subclass it, but you can if you want to. And then do whatever with it. And then in your main, you just say engine.run, and then it goes off and does the stuff for running. Meaning, we have a run method, void run. There you go. This is our run method. What we're going to do with this is have a while loop. So I'm going to full screen this now. So welcome to Game Engine Programming with me. So I want to have a boolean for if we're running or not. It's going to be false by default, and then run is going to set it to true. I suppose it could be true by default because sure, let's make it true by default. It doesn't really matter, I suppose. What is this complaining about? Nothing. It's not used. Well, I'm about to use it, so stop complaining. While we are running, right, I don't want to tie it to the window because we might not be using a window. That's the thing. Because we're using a render target, we might not be using a window. So we've got to be careful to not tie things to specifically a window. So while we're running, we can just say, m render target clear, and then we can draw stuff to it and stuff like that. What I want to do though is obviously poll for inputs. I also want a method for killing the engine, which we'll just do m running equals false for now anyway. It might have other stuff. This could be inline in the header, I suppose, but screw it, whatever, it doesn't matter. So obviously if we're not a window, then we're not going to be able to poll for inputs, and that's fine, right? We can do that another way somehow. Can think about that later. Yeah, we can have virtual methods in here for people to override to do their own polling, I suppose. So how are we gonna poll for inputs if we only have a render target? That's where casting comes in, ladies and gentlemen. If I want to have auto here and just say window, let's say, equals a dynamic cast, right, to SF render window, make it a pointer from our render target dot get, because it's a smart pointer. We then want to say while window is poll event, we want to make an event thing in here. SF event EV, we actually need to include it as well because it's only forward declared in here. It might not even be forward declared in here. I don't even know. Is it? No, I think it's forward declared in the parent window, actually. Let's have a little look. Yeah, it's forward declared in the parent window. So we want to include SFML window event. Event, if I can spell. Here we go, we have the event here. And we can pass it in. This takes a reference, so we can just pass it straight in. So only if this variable can cast to the window, which by default it can because we set it to a window, then we want to poll while this is true. So while we have a input that is being polled, we want to do something. Maybe not while, actually, maybe just if. I don't know. We can change that. We can just, you know, just easily change it like that, though. Doesn't matter. For some reason, while doesn't show that, but if does. What does this say? Oh, yeah, okay. It can be moved in because I'm using C++ 20. I think it's C++ 14 or 17 that introduces this. You can do this, which is really cool. I'm not going to do that, though. I'm going to leave it as a while for now, anyway. What's Windows saying? Can we make const? Very possibly, yeah, very possibly it can, because this is not a constant function, but I suppose I could just make it constant anyway. Sure, okay. I want to do a switch statement on ev.type. We want to say case sf events closed. So if we close the window, then we can just say, we can just kill the engine, which will say running false, meaning this breaks out of the while loop and it does whatever is down here. Also, if I've just realized, I don't think my cursor shows when it's like editing text for some reason, so I apologize for that. You know, you can break so we can break here from the case. Switch is obviously going to be saying there's no default, and this is saying not everything is covered, so we can just do a default here and say break. Nice. This is going to be saying something like, yeah, 23 are not done. Who cares? Right. So if that's happening, we do that, and then we can draw stuff, obviously, and then we also want to display it, right? Render target doesn't have a display method. That's on the window. The window is a display method. And I want to have it all handled like implicitly in the run. So once again, we're going to do an if. I could probably actually do this. Have it on the outside. If window is valid, do that. What's this saying? It's probably going to say you can move it into the thing. Yeah. Well, unfortunately, you can't because I'm using it down here as well. So if window once again, then we can say window display like that. Okay, cool. So this will be the update stuff, and then this will be the drawing stuff. So we can have a do protected a virtual method. Call it tick. Sure, let's have delta time in here. And then another one, call it draw, which we don't actually need anything because we have render target anyway. So yeah, I'm going to leave it like that, I think. So our tick is just going to be called here. Tick. Obviously we need an input for this, so we can create an SF time, which will be called time. And we need an SF clock, which we can create. This should actually be in the loop. We can make a clock here, actually. We don't need it outside, I don't think. Let's call it clock, and then time will just be clock dot restart. Nice. I don't know if I want this before or after. You know, I want it here, I think. And then tick can be time dot as seconds. So that delta time is going to be like 0.0001 or something. Right, something like that, because then you can use it as a multiplier for things. So there you go, as seconds. That's going to be our delta time stuff. That's going to get sent down to the world, to the level, to the entities, stuff like that. So now we have drawing. We can draw. We need to implement it first, though. Bang. So our ticking and drawing currently don't do anything. So yeah, I think actually I might want to have. I might actually want to say SF render target there and call it target, and then also have SF render states for declaration. This will be copied actually. States are copied normally, I think. There you go. So we've got render target, render states. For some reason, this is fine being. This is fine not being included. I don't. What? I don't know why these are copied normally. Because if you look at the draw for this, right? You see you have... No, this has a const. Interesting. So why does the render window draw? I think. Does it? Wait. Wait, I'm being confusing. What? I'm confused. Draw. No, it's a const. Then why is the drawable thing? Hang on. What am I? No, I want to find a file. Drawable. Here we go. This. Then why is this draw? This is not a reference. Why is this not a reference then? I don't know. Very strange. This is going to be a reference. I don't know if it's going to be a const reference, but it's going to be a reference. Then we can say, you know, oh my goodness, render target, as well as whatever states. Let's make it const. We say SF render states. I don't even know what it. Yeah, default constructor, sure. Const reference. But now if I go states dot, you know, shader, I can't set it equal to something, can I? No, because it's constant. So I don't want it to be constant. How does it? How does that work? Actually, hang on. I want to look at the SFML source code. How does this work? Give to me your source code, please. Source graphics render target. When we draw, which is where? Here. Drawable.draw. This states. So the drawable is what? What is the drawable? Let me go into this. Is drawable a member? What is drawable? Oh, it's this. I'm an idiot. This is drawable. Okay, that's what's happening here. Okay, they're calling the draw method on drawable. Right, so passing drawable in, and then the drawable thing, which I can find here. Drawable has draw, which is just being copied. Okay. So that's probably why this is a copy, because otherwise it would need to be a non-const reference. And you don't want to affect the upper layer thing. So I'm thinking I just copy it. Right? That's what I'm thinking. I just copy it. We can change it later. Doesn't matter. It's lightweight enough, probably. Maybe. Yeah, I mean, it's copied around anyway in SFML's API, so I assume it's fine. It's only got, 2 pointers, a transform, and a blend mode. A blend mode is a structure of enums. That seems fine. And a transform is... It's just got a few floats in it, right? It's got a single float array. Okay, yeah, it should be fine, I think. Yeah. So you can extend the engine, override, draw, tick, stuff like that. We don't need to deinitialize anything or initialize anything, actually. So I think the engine for now is done until we make like the world class and stuff. So yeah, for now it's done. Let's make the world class, actually. Let's make the world class. Let's close this. I'm just going to do it like this just because I don't want to use CMake. CLine. World.hpp. If not defined, tails world hpp, then define tails world hpp, end the if tails world hpp, namespace tails class c world, probably world can probably inherit from tickable and drawable, right? Probably. Maybe. Potentially. Maybe. I mean, might as well, because... Yeah, might as well. I'm going to start off by just inheriting from drawable, because I don't have tickable yet, so we can just include SFML / graphics / drawable. And that's it, basically. Let's add world.hpp into here, and let's go add the source file as well. Include tails / world.hpp namespace tails, bang, pretty much. This CMake list, do world.cpp. Right, now then, CMake this bad boy and go to build and open the solution. So now we have world, hopefully, yeah, cool, world, close the object, don't need the object. Okay, right, durable, that's all good. I want to do, I want this to be final, actually. I don't want you to be able to inherit that. It is abstract. It's abstract because drawable is abstract. It's got pure draw methods. So I'm gonna have this be private and override draw. Here we are. It's gonna not have anything at the moment, but this does mean we can have world as a member here. Right, C world, call it m_world. Going to include it as well. Tails world, nice. Now we can say draw target.draw world. Pass in the states there. Not like we really need to, but might as well. There's actually a static default here. Nice. So we can change this to have like global render states basically. You know what, I'm gonna have a variable for that. SF render states, call it render states, like that, and then put it in here. Render states, bang, nice. Okay, cool. Yes, now you can have like a global shader or something. Cool. So the world essentially would work like that. I thought, why is this not complaining that it's not included? Unless drawable includes it, but oh, it does include it. It includes render states. Oh, of course it includes render states, because this is not a reference. Never mind, that's why it's not like crying. Cool. We have our world and stuff. Nice. So, actually, yeah, the world should inherit from objects, shouldn't it? I don't want that. I want it to be like portable somewhat. There we go, inherit from objects. Nice. And I also want to have a friend, because the world is a bit lonely. C engine will be our friend. Don't do anything like that. Forward declare C engine. There we go. Now we have a friend called engine. I don't actually need to do that, I don't think. No, because tick's going to be private, so unless... No. It's fine, whatever, we can do that. Cool. So we have our friend. We also want to, in the constructor, have world.outer equals... Oh, we can't have this as the outer though, because this is not deriving from object. So it does need to derive from objects, but that's fine. Also, something I just realized, since we're doing it statically, we don't need this, but I like to have all my bases covered just in case. It's always good to have a macro like Tails API, for example, in front of the class. You don't need it for templates, but for non-template stuff, it's always good to have it there. Just in case you do decide to go do dynamic libraries, then, or shared libraries, then you don't need to, you know, go through every class and add it. Yeah, it'll be defined, it just won't have anything in it. And what will it be defined as? Just that, really. It'll be in include, and we can call it like config or something. What does SFML call it, actually? SFML is, they use it quite a lot. What do they call it? I think they call it config. I don't actually know. This is in source though, not in include. Yeah, they call it config. Yeah, they have all their macro stuff like API things in config. So if I open up my config thing, obviously we want to say if not defined tails config, then define tails config. Basically every header file you want this, unless you know for 100% certainty that it's only going to be included once ever, but then why are you even doing it in a header file at that point? So then we want to say define tails API, and we can specify what this means later. We just want to have some kind of like temporary constant essentially for it. And we can go around down here, tails API, and then in objects Tails API. Do that, and now we can add it to the CMake lists. config dot. No, this is the source file one. We want the sure reloaded, whatever. Yeah, I just want to find the CMake list. Here we go, header. Config.hpp. Here we go. Okay, do that. And then open the thing again. Cool beans. Cool beans. So now you'll see this is actually going to show up as defined instead of what it was before. Maybe. No, it's because I haven't included it. Hang on. Include Tails config. There we go. Now it's showing up as macro Tails API. Nice. World include. Notice that it still works there because objects includes it. I like to include everything that I'm using anyway, just in case. Just because, I don't know, it just makes sense. And things aren't going to be included twice anyway. So, you know, that also means I should include render states here as well. But yeah, that's all cool. Nice. So, tick. We need to have the tick stuff. World also needs levels to do stuff with. We can have methods, like for example, go public. We can say void open level, and we will literally just have this. Obviously, got to include string. I don't know if I want to have value and move it or const reference. I'm not sure, because how we're gonna do this. Like, what the heck? Why is that doing it in spaces now? Why is it not? What? Anyway, how we're doing this. We're essentially going to open a JSON or whatever, and then create a level object. I think I would want to move it, yeah. I can change that later though, that's fine. Saying it can be static, 'cause there's nothing in it. So open level will be, you know, open level. Yeah, I might have these be protected instead of private. Or just have getters. I don't need this, do I? I don't need to check if it's running or not, because if it's not running, then you'll know, because the program's not open. We can get the world though. Oh, actually, this can't be const, can it? No. Oof. Oh well. Cool. We can get the render target too. This can be const though. Get render target. Because we're just doing render target.get, which is const. Yeah, it's a no accept as well. I don't actually know what that means exactly, but it seems to be good, so that's fine. Get render target. This could actually just be a reference because we don't. This should always be valid, so that's fine. We can have it be a reference. We can have this be a reference as well because, once again, it is. We can have this be const now. No, we can't. Never mind. Because this is a stack variable, so or a automatic allocated variable. So, you know, why would we return a pointer to it when we can just return a reference to it? Because it's always going to be valid as long as the engine exists. So, yeah, we can get the render states as well if we want. I suppose let's do that. Actually, this probably wouldn't be const. That's like, yeah. Actually, this should be const. So this probably could be const, right? Yeah, there we go. Could make a const variation of this. Yeah. Constant variation. What is this saying? Oh yeah, no discard. Good point. C++ something. No discard. No discard. Nice. That's all good. Okay. Now we have our getters of things. What do I want to do now? Probably do the tickable interface. It's been quite easy. It's only going to be a header. So we can say tickable. If not defined, tails tickable HPP. Then define tails tickable. End if tails tickable. Namespace tails. We want it to be class I tickable. There we go. It's I because it's going to be an interface, and we will have. It'll be protected. It'll be protected. Virtual void tick float delta time equals 0. And this will be our class. Should probably have a public this virtual destructor, right? Yeah, this has a virtual destructor. Make it default though. Render target. Yeah, okay, this is all good. Cool. So now we need to add it to CMake and do that stuff. Add the config thing here too. Tails API. Cool stuff. So now in our world, we can say public I tickable. And this will include it, not in the way I want it to though. So include tails tickable. Nice. Now this is saying it's abstract, obviously. So we'll say void, no, we just say tick. There we go. Nice. Now we have our tick stuff, and our friend is the engine, so our engine can quite happily call tick in it. Mworld dot tick delta time. Nice. Cool. I'm thinking of having pre-tick and post-tick stuff in the tickable interface. So I don't know what this is on about. I don't need a copy constructor or assignment or move because it's got no members, dude. Virtual void pre-tick and then virtual void post-tick. So that these can be called on pre-tick and post-tick. The engine is going to have virtual void pre-tick. I could just actually have the engine inherit from iTickable. Yeah, let's do that. Override that. It's going to say it's not available, but public iTickable. They're saying it is, so that's all good. Don't need to be virtual. World pre-tick, and then actually it should be after draw. Post-tick. And then here we can say pre-tick here, and then post-tick here. And this gives us time to do anything we want before or after a frame, which is quite cool. So this is saying, oh, it's not marked override. Yeah, whatever. because objects actually needs a virtual thing here. There we go. Okay, cool. So yeah, this is obviously gonna work there. Cool. So what do we need to do now? Levels, let's say, because the world needs levels. So let's create some levels. Let's actually see if it compiles first. It should. Yeah, okay, cool. Let's add let's add a level class. New text document, level.hpp. Yes. Sure, whatever. If not defined, tails level hpp, then define tails level, and if tails level namespace tails class C level. I'm going to do the rest of the stuff in Rider. Set it to CMake here. Let's put this up here. I want to have some kind of order here. And then there we go, we can have level.hpp. And then we can have, I've only got 3 classes here. Interesting. Level.cpp. Yeah. Get that in there. Include tails/level.hpp. Add the namespace. And that's all good. Add it to here. We can say level.cpp. Cool stuff. Now we can, once again, do this. I don't think we need to close and reopen this. I think it can update on the fly, but I'm doing it anyway. Who cares? Okay, the level will, first and foremost, we need to include the config so we can make it Tails API, and then we need to include the objects and tickable and also drawable graphics drawable. This is going to be public objects, public tickable, and then public SF drawable. And that's going to be our level, and it will just have entities and stuff in it. And this will be final, and it's going to be like, you can't be final when you're abstract, so obviously we got to have stuff. And there's no point in using protected when it's final, so yeah, just make them private. We want tick. This is fine. And then draw. I think those are the only two that I need to override. Or that I need to override. I'm going to override the rest anyway, but those are the only two that I need to. Yeah, and then just, you know, because why not? I'm going to have public, just a temporary spawn entity method. Which could just return null pointer for now. So it's static. Yeah, no, I don't want it to be static. So this will, you know, we'll have like a vector of entities and stuff at some point. So that's cool. Now in world, we want there can be a stack. They can be automatically allocated, can't they? Unless I want to have pointer to implementation, but I don't see why. It's such a small, or I want it to be such a small engine that it shouldn't really matter if I just include a class somewhere, because the size of world is 32. The size of objects is 16. So I don't actually know what I'm talking about here. I don't really know what I'm talking about. So we can have C level, which we want to include, but it's not going to do it in the way I want it to. So let's do it manually. Tails level. Let's call it current level. right? And then here we can say C level get level, return current level. Then we can have a constant version. These can both be no discard. Cool things. And then in the tick, we want to say current level. Oh, this is the level tick, not the world. Here we go. Tick, current level dot tick, which we can't access because we need to forward declare world here and then declare as a friend. Here we go. Tick, delta time in there, and we'll say target dot draw current level with states thrown in there. So there we go. Yeah, don't need this. So our world does that. I'm also going to do pre-tick and post-tick as well. We want to say current level dot pre-tick, and then current level dot post-tick. There we go. So pre-tick and post-tick for that stuff. Now we want to handle opening levels. We don't want to handle it fully, just do basic, blueprint of it. I'm thinking we have another variable called the level to... the thing is, this needs to be a pointer, doesn't it? Because I want to destroy the memory. I only want one level to be available at any given time, except for when we're loading a new one, because I only want to load the level on post-tick. So I think it needs to be, otherwise we've got two levels loaded in memory. So I think I can just have a unique pointer here. And that should be fine. Level to load. So then open level, we can say level to load equals make unique level, and the level will have a let's make the constructor now. Actually, it'll have a constructor for the path. And I want to have a private thing with string, call it m_path. We want to move it there. Cool. We'll probably have a method called like reload or something for this. I'm just going to have it be not constant or a reference. Cool. So now we have that. We can post ticket, and then we can say if level to load is valid, then current level will equal hang on, what am I doing? Current level will equal level to load that, where it will copy it, and then we say level to load dot reset. So we want to copy this level into this one. What would be better is moving it. I think that's what I'm going to do, actually. Let's just do that. So we don't copy it, we move it instead. Yeah. we want to have the pointer thing here, and the pointer thing here, and the pointer thing here. And we're at the pointer right, there we go. So this is obviously saying that. So we want to have that level to load, and then we want to say current level equals std move level to load, then reset level to load, which it'll be reset anyway because we just moved it. But so basically, actually, I wonder if we can just do like dot reset std move level to load. No, okay. Anyway, we'll just do equals then. So basically, when we open a level, we do that. We do this. This will then like load whatever it needs to. At the end of the frame, we say if it's valid, which it is, then we know that we want to transition to another level. We then move the level to load into current level, reset level to load. We've now successfully transitioned into the next level. Pre-tick is then called on current level, which is the new level that we just loaded. We go through that. This is invalid, so this will do false, so we don't do this until we open another level. That's that, basically. Yeah. The only thing we want to do now is make sure that we have a default level. So in the engine, we can then say world dot open level nothing, basically. I suppose we should have an init member function in the engine, because you're not really supposed to do stuff like this in the constructor. The constructor, I think, is only really meant to initialize variables, not call like, business logic as it's called. But the business logic here is only really doing this stuff. But this also means that the first frame will not have a level, because on post tick it cares about that. So I'm thinking, instead of calling open level, we can just say set level or something. Actually, no, we don't even need to do that. We can just say like dot current level equals like make unique this, and it'll just work. We can like refine this later. This is fine. So for now, anyway, this is fine. So we have our engine, we have our world, we have our levels, which can be loaded. And this will be our default level to load, which we'll get from like an ini file or something. So yeah, to do default level to load. So we can do an entity now, or I actually want to do the input stuff. I'm thinking it'll be a singleton. I want to try that. I haven't really done that yet, so let's try it. Input doesn't need to tick, it'll be very simple. So input manager, or just input. Call it input manager. Can change the name later if I need to. Class C input manager. Doesn't need to inherit from anything, I don't think. Does need config. Like that. Put it here. Then in source we can do the same thing. input manager dot cpp include tails slash input manager dot hpp namespace tails. And here we can say add input manager dot cpp. Nice. Okay, now we can rebuild, or now we can regenerate the build. Here we go. Processing stuff. Okay, input manager. So I think the best way to make a singleton, I believe, is I'm actually going to have this be private. Is to have a static thing here saying get. And what this will have is a static automatically allocated variable, just call it instance, and we can return instance. And because it's static, it's made, and then I think it's just made once. So I think this is the kind of way you want to do it. And then, you know, in the public, we can just say static, you know, test func or something. Why is this? Oh, because it's not good. Return. And then we can say, you know, get dot, you know, something if we want to get a member. Right, we can say dot test, for example, saying expression unused. But then somewhere else we can just say C input manager double colon test func, and it'll just do whatever it needs to. That's the kind of plan. So what I'm envisioning with this input manager is we have stuff called, we have what's the name? I can't remember the name of it. Basically a base interface class for every kind of a base interface class for every kind of input to inherit from, and it will have, like, you know, generic functions like is button down and stuff like that, which will just return a bool and take in an int. That int can be like an enum or something. Yeah, I think doing something like that would probably be best. So yeah, we would need class, let's call it I'm going to close my window quickly. I've returned. I went to put my washing in the washing machine. So we need a input device. Yeah, we probably want to have like an action as well. Let's do a bit of struct. And this will have a vector of unique pointers to input device. Which is essentially the keys, as well as like a friendly name, I think. This will have a vector of actions. Call it actions. Here we can say, you know, is action, no, is device key pressed int key. No discard. We can just return true for now. We actually need to make the thing for that. Obviously, since it's an interface, it'll be just the header. So we want to say input device. And this will obviously be tails/config. And we want to let's make it public. Let's make it a structure, actually. No, let's make it a class. Let's keep it as a class. We want to have it be virtual bool is button pressed. That'd be the button 0, right? And then we can say, virtual float get scalar input value input, like that kind of thing, right? Here though, we can just return 0. So this button pressed is going to be the main thing, because there's always going to be a button at least, but there's not always going to be scalar. And then we can have like 2D stuff if we want, but this is kind of the base thing for this. And then I want to make a keyboard device. Here. Oh wait, it's just a TXT. Here we go, if not defined, tails, keyboard, device, HPP, and then define it. So you should never be interacting with this directly, basically. So what's the method called? It's button press, let's copy this. Override. And then this will be using SFML keys, essentially. This is why I'm abstracting it, because I want to use SFML slash... I don't even remember what the thing is, I'll just do it in Rider. Yeah, say keyboard device.hpp. And then we can make a source file for it as well. This is a text file, not a CPP file. Tails / keyboard device namespace tails. Okay, nice. So we have that, put it here, keyboard device.cpp. Okay, let's regenerate it. Going to build, open it up again. Okay, so I just realized I could probably use a map for this instead of a vector of actions. Doesn't really matter, I don't think. So what we can say here is return. Well, we're going to do a for loop first. Let's do a for each in devices. device. I want to have this be a reference because I don't want to copy the. Oops, I don't want to copy the the unique pointer around. That'd be bad. If actually, no, yeah, we can have a boolean, call it results will be false. I think this is a generic way of doing stuff like this. If device is button pressed, key, then actually no, we can just return true. We don't even need this, and then we can just return false here. Never mind, we're all good. It's going to say you can replace this with a range. Yep, I don't care. I'm going to change this method name to is device button pressed. Change this to button, just so it's consistent no matter what thing there is. What is this saying? If we make const. You know what? It could be made const, couldn't it? Yeah, okay. Yeah, so we can now make a static bool for is action pressed. With this, and then we can return. Well, we're going to find it first, haven't we? So we're going to say auto it equals std find in actions dot begin and end find action. I don't know what's up with this. Oh, non-static. Get dot. Get. Oh goodness me. Get dot. There we go. And then we can say if iterator is not equal to actions dot end. So if it exists, then we can return it is device button pressed. I'll have to work that out, but keyboard device. Where is this even? Here we go. Okay, so we want to have SFML probably window keyboard. Here we go, and we want SF keyboard key. If button equals underscore key, yeah, we can just return. No, we don't want to do that. What am I doing? Wait, what am I doing? If SF keyboard is key pressed. Just do that, right? No. Anyway, we can just return this if it does work. I need to look up inst to enum. Oh yeah, you can static cast it, can't you? Static cast to key. So we don't actually need this. Need to include it here though. So That's good. So obviously, is action pressed? Instead of having a list of devices, we should have a list of keys that could be used with those devices. So vector of ints, calling it buttons. Saying is device button pressed. Buttons. I think we want to have the type of the action too, right? We don't want this input. Because if any of these are pressed, basically. So we want a unique pointer to the input device. Call this device. We can say if device is button pressed button. Yeah, so this could be const. But it's also saying, oh, it can be moved to whatever. So basically, we have an action. We give it a name. Currently, it's not in use, but it might be in the future. We give it the buttons that we want to trigger it, and we give it the device that we want it to use, i.e., keyboard or whatever. Now, do we? Because the problem with this is we can only use either keyboard or, whatever. So maybe having a vector of devices as well. To go through them and see if any of the buttons on any of the devices that it has is true. Or in the input manager, in the input manager, have a vector of the devices instead of in here, so that then it just queries every device in the input manager. See what we can do there. Because obviously here we need some way of having the device, right? So I'm thinking we just have a pointer here called a device. Then here we loop through the stuff. So we do a for each through the devices. Create device. Device not get. Let's say get. There we go. And what we want to do is don't return it. Say if it's valid, return true. So if it's pressed at all, if any of the devices, yes, these would be like registered devices, right? So we can register a device. So be templated. We register an input device, and we say m devices dot in place back make unique. Static assert it. is base of input device failed to register input device. It does not derive I input device. And then we can have a private constructor here where we register the keyboard device, for example. That's the default one where it's always registered or something. And then we can do the same thing here, but just with, is action pressed. Have it be a string instead, where we want to find a string. So for each action, action object. For each action object, we're going to say if action object dot name equals action, then we do this. Return is action pressed action object. So I'm still not completely sure on this, but yeah, and then we can add an action which will return action. So actually, let's just do this. There we go, string name and a vector of ints for the buttons. And we can say mActions dot in place back name buttons. We can return gets actions dot back. We can also do an action just for this. There we go, action. Here we can say get actions dot in place back action return actions dot back. There we go. So I can add an action, we add one, we specify the buttons that we want to use. We can say like, add button, int button, buttons dot pushback button. Now, I feel like, because I have a device now, I feel like I need to have something which connects all of the enums for the inputs, like controller and keyboard and stuff, to an int. Like, for example, a structure, right? A class interface called like I button, right? Like I device button, which can take anything. You can initialize it with anything, and it just holds it as an int internally, or it holds it as its own thing internally. Yeah, I'm thinking we have something like, I device button, and then keyboard button from iDevice button, which will have, let's say, a constructor for SF keyboard key. You know. If you know the key here, and then we say, actually no, we would have public int button. This would just say button equals, static cast to int from key, for example. So this would just be a conversion kind of class, basically. I'm thinking, but I'm not sure. I'm going to try using it. See, input manager, add action. We want to add, jump, and it's going to be a list of ints. So we want, SF keyboard, space, and that actually works. Is action pressed, jump. Yeah, so we can just do that. Okay, that's fine. We don't need the conversion thing then. Or if I got, the joystick, I don't actually know how to use this. Anyway, there you go. It's okay. So we can just implicitly convert it to an int, so that's fine. Right. So that's kind of what I want to do with the input. Aha, unless we get a big error in the input manager. Tails action does not define this operator. The equals. We don't know if the equals is a thing. I assume vector uses it within itself, so we can just define it. We want to say other. We want to return if name is equal to other.name and buttons is equal to other.buttons. There we go. Nice, and if we do release, then that works too. Cool. So it builds. It probably won't work in runtime, but I'm not testing that at the moment. So I'm going to leave it here for now. This is the singleton for the input manager. I don't even know if this say do singleton. I assume it is. There'll be singletons for the input manager, the asset manager, and then the audio manager. Those would be the 3 singletons, I think. Might be missing one. And then the level still needs entities, and once that's done, all that's left will be the UI stuff. And then the engine will pretty much be done. It will just be like, different, small things. And did I forget to mention also adding Angel scripts as a scripting language? That's going to be the most difficult thing in this entire engine, because I've never done something like that before. Adding a scripting language as support. So there you go. This is the kind of remake, redo thing of my Tails game engine. I hope you enjoyed it so far. It's coming along decently. Yeah, it's not got many things in it because it's intended to be a small thing. It could just, the input thing is probably still overkill, right? All it needs to do is just have a list of, well, yeah, it is a list of ints, isn't it? Yeah, I want to abstract that as much as possible, so you can mix in, controller buttons, keyboard stuff into the same action, and see if anything is pressed at all. But that's for another video. So I hope you enjoyed whatever this was.